All right. Hello, everyone. Let's wait till people gather up. Oops. Hello. All right, let's wait a few more minutes and we'll start. A few notes in advance. Today's lesson will not have a Kahoot because I think it's way too much info, I think, for Kahoot, and it's not that useful to have a Kahoot from it. That's why I would like to make it more practical and just do more demos and have a step-by-step guide how to do debugging in C# and all the nice features coming with it. Actually missed one. I'll add it later. Okay. I think we can start. So, debugging. This is lesson 6 in our bootcamp, and I'd like to talk about where did the word debugging come from? What is a debugger? What is a breakpoint? How do you see your stack trace? How do you use a watch, intermediate window, debugging requirements, and how do you debug external process? So let's start. Yeah, and origins of word debug is literally that there was a moth in a mainframe computer, and you can see above how that computer looked like, and you can see below the person, Grace Hopper, who coined the term debugging. So they literally had to remove a bug from a terminal, from a mainframe, because it was causing unexpected problems to happen. And the process of removing the moth from the mainframe was called debugging. And that happened in the 1940s or so. And now let's start with practical things. The most basic thing of all in debugging is a breakpoint. So breakpoint is a point which specifies which line of code will be paused during code execution. And you can place it by moving your mouse to the left side of your IDE and clicking it, left-clicking the spot, the line that you want. So I want 47 line to be marked with a breakpoint, and click, and a red dot will appear indicating that it will be paused at that point, at that line. Alternatively, you can just put your cursor, let's say, in line 49 and hit F9, and your program will be paused there. A breakpoint will be placed. Before you can do debugging, you need to make sure that first you run your application in debug mode. And second is that trace constant is on. Otherwise, you won't be able to debug. You don't have to have debug constant on because it's used for different things. So debug mode and trace constant. This configuration doesn't really matter, but just make sure that, this is the configuration for debug. So if you're on release, even if you're in debug, it won't matter what you change in release. Now, to start debugging, it's quite simple. You just press the arrow button here, and it will put you to debug mode. or alternatively, you can press F5 and it will debug. And debug mode is even more simple. Essentially, you have three buttons. So 1, 2, 3, and it literally visually explains what it does. Step into, step through, and step out. Step into goes inside a function that the breakpoint is at. Step through passes it and moves to the next line. And step out moves out the function. So it doesn't skip any code. It will simply break at a different point based on the buttons. And those buttons are, if you want to step into, it's F11. If you want to step through, it's F10. And if you want to step out, it's Shift F11. I will put it in the slides later. And I'll link the slides right after I'm done talking. Next thing that's very useful for debugging is knowing the path that your application takes. Like, through which lines did your application travel to do what it did? And here you can see, even though you have no idea what code was executed, from call stack you have a clear picture what functions were called before it got hit by a breakpoint. So from this picture I can tell that it first started in main function, then it moved to step 1. From step 1 it called step 2, from step 2 it called step 3. So topmost record in the stack is the latest function your code is at. So call stack is really cool thing if you want to trace back one or a few more steps back where your program came from. Watch. Watch is a cool thing because it lets you track values. Values of variables. And in fact, it even lets you track expressions. For example, you see I have a variable named A4, and A4, I can multiply it. I can take a square of it, and I'll have 16. So you can do really cool things with it. So yeah. Watch is great, especially when a variable leaves its scope. So even if a variable leaves a function, I'll still see its value unless I hit the refresh button. So it's nice to keep track of all the variables that I have gone through, that I have faced, and that are actually useful and needed. However, a more common one that you'll probably use is locals. Locals is literally your local variables. And what you see here in the picture, A1 equals 1, 2, 3, 0, 4, this is just resharper thingies, but those are locals essentially. And you can see all those locals below. All the locals, nice and clear. Name, value, type, all the info that's needed. So I don't need to do anything, literally anything in here. By the when I step into line 61, when I end up in that line, I'll see automatically all those things. So it's nice, it's really nice to track a local state that you're currently at. It's really a great way to do so. And C# has a really cool feature, not C# but Visual Studio. Basically, when your program fails, it will break at the exception point, at the point where it threw an exception. So for example, if I got null reference exception at line 17, it will stop at line 17. So before your application closes, you can check the locals to see the local state and other thingies, so that, you know, you have the context before your program terminates. You have the context at which your program failed. And yeah, by default, it breaks. However, you can disable breaking on exceptions if I have a tick, or if I remove those ticks from here, then I will also not break. Recommended to just keep those settings. We talked in the beginning about basic breakpoints, but there are more useful and complex scenarios. For example, especially in a loop, when you want to break at a certain index or at the end of an array, and then conditional expression is your best friend. So here you just basically write an expression, a logical expression, I is more than 0 or so on, and it will stop as soon as this expression is true. In all of the cases, it will not stop. So it's really silly to just, you know, keep stepping into the same line in an array multiple times if you can simply use a conditional expression and break there. And a little nice feature, you can even have a message come when your breakpoint is hit in the output window. So this is really good stuff, and this I literally tell you everything that you will need to do to do debugging, and as a professional you won't learn anything more. This lesson content is basically it, so it's really good. And lastly, well, not lastly, I forgot one slide, but I'll mention and demonstrate it live, is a dump window. Basically, when you have a breakpoint and your program is in debug mode, when it's paused, you can literally take a dump of your program, save it in .dmp file, and if you open this DMP file, it will load your program in debug mode with the state that you had before. So for example, if your program crashed, you can, well, what happens if your program crashes? It will throw an exception. So if it throws an exception, it will break. And if it broke, then it means you can still do something with its state. So you can click debug, go all the way down and save dump as. And what will happen is that it will save the current program state. It will load the state that caused crashing. So it's really nice way of figuring out what went wrong. To be honest, I rarely see people do that, but I don't know why. I think this is quite useful, especially for complex programs. So I don't know why don't people do that. So yeah, that's it. One more thing that I didn't mention is intermediate window, which I'll put later after lesson. And now let's start with a demo. I'll start with intermediate window. So let's do some debugging. But before that, do you guys have any questions? Because there was quite some info in quite some short time. But it's all in the slides and you don't need to memorize everything. You just need to practice. Any questions? Slides, man. Slides now. All right. So let's start from the basics. First, let's see what happens if I run my program in release mode. So if I go to release mode and try to do debugging, you see it immediately warns me saying that I'm debugging release build. So it says breakpoints will not be hit. So I cannot debug really in release mode. I have to select debug mode. So to start debugging, we make sure you select the right project first, of course. We have two projects in our solutions normally, one for tests and one for your program, your implementation. So you can select tests, but you cannot run tests because this thing to be ran, it needs to be physical, standalone application, and tests are not standalone. So I select the only project I have, so the console application, and I hit run. And I put the breakpoint here in line 14, and thus when I ran my program, it stopped. So it is there. Now, the thing that I wanted to demonstrate. You can change status of your program during its execution time. And you can do it actually in two ways, which is fascinating. And I didn't figure this out until like a year ago or so. So we have this intermediate window. And what this window lets us do is that it lets us change basically execute code while code is running already. So you see, I have a console. I'll actually put those into separate windows. So I have my console window, and look what I can do. Boom. System.console, probably. Console, right line. Right line. Hello. Can I not execute it? I wonder. Let's try again. Console does not exist in current context. Okay. Okay, I cannot do that, apparently. But let's go for a more simple example. We have a status variable, right? So I can say status is good. Note that right now status is bad. If I do this, you can see that status suddenly changed. So what does this mean? This means that I can change my program state without touching the code. So I don't touch any of this code, but I can tinker with the state. And in fact, I can do many cool things like for while more like for. Let's print good a bunch of times. I plus and status good. Not sure if I can use multiple lines. Maybe not. No, I cannot, sadly. Joshman said to debug.writeLine I can use. So if I go to the output window, you can see the output appear there as well. Well, apparently not. Debug. System diagnostics. Now it should appear. Debug window. I think there is debug window somewhere. Maybe not. But anyways, my point remains. You can change status from this part, and you can even do as interesting things as, for example, well, it's trivial case, so again, I cannot show you yet those things. But I can do something like creating a text file, for example, and writing my object state in a text file. Demo.txt. The annoying bit is, why is it so picky now? Yes, it does. Yes, it exists. What the fuck? It's pretty weird. I don't know why it's not working. System.io should work. Well, no matter. In future lessons, I'll show this more accurately. Now it's not much value. This will be demoed in other places, so don't worry about it. Anyways, let's continue with other parts of debugging. So if I press F11, or if I press step into button, it will step into that function. And I can also track the status of application in the console window as well. So now if I implemented console.writeLine function, it would step into this one, but it will not because I don't have code for this function. So for functions that I haven't made myself and that I cannot debug, I won't step into. So step into and step over for functions like this will be identical. So if I click this, you see step 1 got printed. And if I can again step into or step over, because next one will have to move to this function anyways, so it ends up here. Now console.writeLine, again, if I do this, it prints there. And if I do this, it prints there. Now the interesting part, here's my call stack. What does it mean? It means that right now I am at line 87, as you can see here. And it means that my path of travel was here in program main function. And then I moved to step 1. Basically, which line called another function. So line 75 called this step 2 function, and line 81 called step 3 function. And inside step 3 function, at the moment, I am in line 87. So it literally shows the full path, how I got there. Really useful when your program gets complicated. All right, next, let's see. So call stack, use it when you want to know the path of your application. How did it get there? Let's demo a watch. So let's debug. Let's put the breakpoint here. Actually, let's put a breakpoint here. All right, and look at this interesting thing. You see, so what happened? I started my program here, scoped watch demo. Well, I can show you from the locals, from the call stack. I started my program here, and then I went to this function. And look at how beautiful it looks in the locals window. I open my locals window, and I see a variable name, value, and type. And look how interesting it starts populating. You see, like A1, A2, A3, A4, and then I start exiting scope. I no longer see end, I no longer see 4, I no longer see 3, I no longer see 2, I no longer see 1. And then my scope got incremented, my condition is checked, and I continue my journey again, moving and seeing more, and now seeing less. Also note how I am at this line, and I already know that that those have such values. But I think if I restart this again, for the initial call somehow, you see A1 was 0. I cannot explain this behavior. But this is the beauty of debugging. It's like exploring code and trying to understand low-level stuff, how things work, how they behave. So it's really, it can be really fun messing with it. Now, let me show you the interesting thing that I showed in the last slide called, what was it called? Memory dump. So A1, let's say A1 is 15. Let's say A2 is 29. And let's continue. So A1 is 15, A2 is 29. I'll do it again. Whoops. A3 is 11. Random numbers, just ignore that. I'm just changing the values, you know? And end is memory dump, for example. So I changed all those values. And let's say I did something like this, or maybe some bug happened. Maybe I want to share how my program works with somebody else. And how do I do that? And apparently I can share my program state. So I do save dump, save, and now I can stop debugging. I'll take a screenshot for the values I had as a proof that this is the state I was in. Like this. So this line and those values, right? So I move this here, and I am stopping debugging. Now I will go here and open this dump file. It will take me to this window. This shows basically dependencies that were loaded and just some other metadata about it. But the key point is here. In this part, I can continue by pressing either of those debug buttons. So if I click this now, see what happens. I'm exactly at the same line I ended my application, and my values are exactly like the values from the screenshot. A1 was 15, A2 was 29, A3 was 11, A4 was 49, and end was memory dump blah blah blah. So we just saved our program state into a memory dump and loaded it back. Pretty cool, right? Again, I cannot continue because that's the state I was at. So it has a state, it cannot continue, it cannot run my program. Next. So I just demoed the locals window. And now last one, conditional breakpoints. So as I mentioned, if something goes wrong, if you have an exception, your application will be paused. And you can inspect the state at which it failed. So I see I have null reference exception. And I see that, well, in my locals, I can see that the index for array, for the loop, was at 31. And then I can note this if, so when index hit 30, I changed numbers to null. So when index, when loops ended its iteration and started over, numbers were null. So when I tried checking null, checking length of numbers, well, length of null was actually what I was checking, and thus I got null reference exception. So having a context when application fails is really a good feature. Also, note an interesting thing. If I click output window, you see this RIP message. Well, that's because I have a conditional breakpoint. I put the breakpoint in line 31. And if I click conditions, you can see that if index is 30, and this doesn't have to match this condition, it just happened to. So if index reaches 30, I print this message and I break this on this condition. Actually, I don't break on this condition because I have this tick on. If I remove this tick, let's see what happens. If I remove that tick, the moment the index hits 30, it breaks, it pauses the application at this spot. Right. And I can see what happens, and I can prevent it from happening if I want to. I can again do that thing and stop it. So I can say that numbers, for example, is that. Numbers, not number. So now if what happened, I set it to null, but then in my intermediate window, I set it to a new int array of 100 spaces. So I reset it. So now if I continue, and let's put the breakpoint over there, and this, you see, lets me run execution to here, so I can actually run execution till the end of function. So let's try it. Now you see it didn't crash anymore. We basically fixed a bug. We worked around an issue in some way, at least for testing purposes. And if I see what the state was, you can see that, well, of course, at index 30, I created a new array, but then I didn't set it to null. So all the other array elements are simply index. So this is the result we got. And yeah, you can explore the individual object states, pin their values if you want to. It's pretty cool. Visual Studio has nice features, nice debugging in terms of that. Right? So consider this as your own portable little watch that is for a single variable. But if you want to have a full watch, it's here. So if I do something like numbers now, you can see that I have all the numbers here. And I can expand and see the same thing as I did there. And the cool thing is if I leave the function, which in theory removes my numbers, well, I cannot inspect them anymore, but I still see their latest shallow state, their latest high-level state. I know that numbers had 100 elements in them. And even after I left the function, I still know that. And I still know the same things that they were, that I was at 30, that numbers had 100 elements, and that first 3 elements were zeros. I still know that. However, if I click the refresh buttons, nothing happens because I cannot. And if I click a refresh button for this one, it says numbers do not exist in the current context because they're out of scope at the moment. They no longer exist. They are garbage collected, no memory taken. All right, so this is watch window, basically for having some values that you want to pin. You can also put stuff in the watch window a bit differently. So let's run it again. let's say I want to put I in the watch window, right? So I can right click on I and add watch. And here you go, I have I. What if I want to see what I square looks like? I can do that, and you see it's squared I. But if I want a cube of I, again, it lets me do all those things just that easily. You know, now we have numbers at index 30. And the line that follows will make them null, which will crash an application. That's a part that is a bug of this program. So when debugging, we can also do little hacks and tricks. You see this little arrow, it's there not for no reason. It says, this is the next statement that will be executed. Did you wonder what will happen if we grab this and move it over there? What happened is that we skipped this line. We basically ignored this statement and jumped to the next lines. And you know what's the crazy thing? It works both ways. So if I want to go back in time, I can in debug mode. So it's really cool to be able to jump back and forth in state of your application. And it's probably the ultimate way of just playing around, messing around, and being crazy with your code. So explore it, it's really fun. So if I move and pass this condition, it means that it will never be hit again. So if I continue, now I don't need any hacks. And you see numbers now are from 0 to 100 properly. So that's pretty cool, right? Yeah. Next. Next thing. So we can move around. I think that's all. Right. Jump in time. So maybe a better demo of what I had in mind would be this one. Let's put a breakpoint there. Actually, there. Okay. Oh, two more things. Good. I remember. So basically, we take a word from a list of words and we make a sentence out of it, right? So after 3 times, the word becomes light gone dark. Let's make it a bit more clear what we mean. Let's run again. So we run 3 times, and after 3 times it's light gone dark. I accidentally ran it 4 times, but the point remains. Light gone dark, for example. Now, as I said, I can work around this. I can jump to this place, and hit the point and work around the system. So at the moment I'm at willing word, and I can simply stack it as much as I want. So my result now will be, you see, light gone dark, sign, willing. So you can jump back and forth in your program and execute just the parts you want in debug mode. Very convenient. And you can skip stuff, you can change stuff, and it's pretty cool. So let's skip that. And another cool thing, I can actually modify my program while it's in debug mode. So you see, normally this program would terminate at this line. However, and with this text. However, I can say not today. And I can move my mouse cursor over there, my statement execution cursor over there. And if I move this cursor here and run it again, I don't want to run this, so I'll skip it. But the point is, I just literally typed a new line of code and it got executed. So there is a requirement for this though. You cannot execute code if your application is running. You have to have it in complete pause mode in order to be able to have this live editing mode. For example, if a website is processing a request, even though virtually it doesn't do anything with directly your code, but things are happening under the hood, so it needs to be at a complete halt for it to be executable, for it to be modifiable within the debug mode. So keep that in mind. So yeah, I mean, you can literally try all sorts of things while your application is running. For example, you don't know how to take the first symbol of a string, or you don't know what will happen when you take an int, let's say a character that you cast to an int, and you can do that here. So you see it gets converted into letter code, ASCII code. What happens if you cast it again to character? Oh, I should have moved it up there. So, okay. But you get my point. You can play around with it just that easily. Now, how do you debug an application that's published, that's installed, that somebody already has? Well, there are two requirements. And those requirements first are, again, your application needs to be built in debug mode. So when I build it, I make sure that it's in debug mode. And then you will have to have the DLL and the PDB files. DLL file is basically your code file, and PDB file is basically the file which allows you to step into the DLL. So let's try it out. So we built this application, and let's stop it. Let's do something that will prevent our application from terminating. So press any key to continue. So if I run this, press any key to continue, I press the key and it continues. Now if I build a solution, we see build succeeded, all good. So now I can go here and run the same application. But keep in mind, this is already something that other person can run. This is already built. This is not run from IDE. This is run from your other process. So I literally ran an external process. This is not ran from my IDE, but I can debug this as well. So let's have split screen. So I press debug. And attach the process. And now I need to find the process that I'm running. And the best way to do so is through here. So you can see the matching paths. You see? 0 to hero, source, and so on, and then .NET Core app, and then chapter.exe. So this is exactly the one that we're running. So I click attach. And now it puts it into debug mode. And now let's put a breakpoint here. And here's the thing. If you correctly wrote it, the right process, and if it's in the right build mode, your breakpoints will be red. So if I press F10, I mean here, you can see that now I'm back in my IDE and I'm debugging again, pretty much. So all good, I don't care about this. And basically application closed, debug done. I debugged. However, if I fail to debug it properly, if I cannot, or what is the hint that I am debugging it wrong, if I build it in release mode. So if I go here, and do build, I should have put breakpoint there. Okay, if I go here and I do build, and if I run my thing again, and if I try to debug it again, actually this is the correct one, so I'm debugging wrong one. You see I stopped debugging, but that one is still there. But this is the wrong one. I need now a different one. Oh, right. It's still in the same folder. I was supposed to open the one in release. All right. So let's refresh. And you see this one now is in release. So I do attach. And now you see the breakpoints are suddenly white. And this is a hint that something went wrong and that you cannot debug this. So stop debugging, not gonna happen. So yeah, that's pretty much it. I think this is all I wanted to talk about for this lesson. Do you have any questions? This is literally all you need to know for debugging. There is nothing more that you can possibly need. Regardless of your level, that's pretty much it. The homework of today is quite interesting because you will have to use debugging techniques and solve a puzzle. So I hope you like it. No tests, just a puzzle. So the homework is here. and you have the task in the README this time. There won't be shit code that you'll be needing to fix. You'll have to solve a puzzle. You'll have to basically figure out what the passphrase is using debugging techniques. So you'll have to input the right stuff. And if you don't, well, you won't progress. Yes, I'm asking you to hack NASA. Yet. NASA has nothing against you yet. I actually don't know. I think so. You should make a PR explaining what you did and what is the passphrase. Oh. Okay. I totally said NSA, so it's okay. Anyways, I will be reviewing PRs that you guys made so that we're back on track. Yes. So I think this is enough. I hope that the lesson was useful. I hope that you're not disappointed that there is no Kahoot this time. But there isn't much that I could ask or show more about debugging. This is literally it. A useful skill, practice it, because you will be spending quite some time debugging. Yes. Alright guys, see you next time. See you on Saturday. On Saturday we will be moving forward and we'll be talking how to work with string, with all sorts of string operations. Bye bye.